So please confirm if my screen is visible to all of you.
Sir, it's visible.
Yes, sir.
Screen is visible.
Thank you.
Yes, sir.
Thank you. So yesterday we had gone through 5 network functions, and today we'll try to cover rest of the network function and other aspects of the 5G core architecture for 1 hour. And in the second hour, we will switch over to 5G quality of service, how quality of service is managed in 5G. So today will be very, very packed sessions, one after another. So let's continue. So I'll try to cover all these aspects. Additional 5 more network function, that is NRF, network repository function, AF, application function, authentication server function, network exposure function, network slice selection function. We will also talk about the service-based architecture, 5G service-based architecture. Yesterday's session, we talked about reference point architecture, which even Mr. Tejpal was pointing out that we can use cloud native network functions. So that we will be covering today. And since it is service-based architecture, then we'll talk about service interfaces. We will also look at the roaming architecture of 5G. In case of a roaming, how the architecture will look like. Then we will also cover the data storage part. In 5G, every network function will not have its own data storage, but data storage will be a common. And in 5G, there is a concept of non-3GPP access. That means even the landline systems or other broadband systems can be connected to the 5G core. So we call it non-3GPP access. So within that, we will talk about untrusted non-3GPP access, trusted 3GPP access, 5G residential gateway access, wireline access, fixed network residential access, and then we'll also talk about some devices which do not support 5G on non-3GPP side, but still they can connect. And then finally, we'll talk about ATSSS, that is access, traffic, steering, switching, and splitting. So it's a very lengthy topic today, but we'll spend some time on each of it. So let us start with 5G service-based architecture. Yesterday, the architecture which you saw was a reference point architecture. Today, this picture, if you see, this is a service-based architecture. So yesterday we had talked about user plane function. If you recall, we had also talked about session management function, but policy control function, access and mobility function, and the UDM, Unified Data Management. These 5 network functions we had talked about, and RAN part, those radio related aspect we have already covered, and this is your user equipment. So today we'll try to cover like NRF, application function, NSSF, AUSF, etc. So before we proceed to these network functions, let me tell you, as we were discussing yesterday, that in case of 5G, the component or the network function which handles user plane traffic has been segregated. So this is the lower portion, a bit highlighted, you can see. It is the user plane part of it. When I say user plane, I mean all the data traffic related to the user flows onto this plane itself. And here itself, yesterday we spoke about PDU session. So in this area itself, a PDU session gets created. The upper part is your control plane. So all control related functions are taken care by the control plane. So now you have distinct control plane and distinct user plane, and it is different compared to 4G because in 4G, some of the network functions were doing functions related to user plane as well as control plane, whereas in 5G it has been completely segregated. So user plane and control plane has been separated. So this has enabled that this portion, the user plane portion, can be located near to the user. Like, so your control part can be centrally located. So normally today in India, deployment is either central or zonal. BSNL has zonal systems. Some of the private operators have central. But with 5G, the user plane part can be located near to the user. So that will allow better latency and also local services to be offered to the users. Now in this service-based architecture, the next important thing which has happened is that the hardware and software are disaggregated. So what I mean that up till now in 2G, 3G, 4G, when you buy these network functions, there will be a purpose-built hardware and software supplied by these OEMs like Nokia, Ericsson, Siemens, etc. And you have to always go to them for any expansion or the new network function. But in case of 5G, you can buy hardware from any generic hardware, commercially off-the-shelf hardware, and on top of that, you can actually deploy these network function as a software. So all these network functions, PCF, SMF, AMF, is nothing but a software application which can be deployed on any hardware, any generic hardware. So that is what is the difference. So this has also enabled deployment of 5G network function onto a virtualized infrastructure or cloud infrastructure. So telco can have their own data center, own cloud, or even they can hire services of private cloud services like Amazon Web Services or Microsoft Azure or Google Cloud Services or any local. So in India, there are a lot of data center has come and they would be offering their data center for any commercial use or application. And we call this architecture as a service-based architecture, all because every network function exposes some service which can be consumed by any other network function, right? So a network function is a producer of a service, and also it may be a consumer of service being offered by other network functions. So it is just like a web service or API based service, right? So this interface is called API interface, right? So now there is no point-to-point interconnection which we saw earlier in a service-based architecture. It is just a producer of service and consumer of service, and they can talk to each other on API. So that is the concept of service-based architecture, and they talk to each other on API interface. Even if some outside application want to talk to the 5G network, they can do so on the API itself. There is a network function called NEF. So this exposes network exposure function, API outside, and any other system can connect to the 5G network. So example can be, suppose you have OSS, Operation Support System, or Business Support System, BSS. Those would require certain logs from the 5G network, certain data from the 5G network. So they can connect to 5G network through API, through NEF, and use that data. Similarly, any third-party applications, if they need to be part of the network, they have to connect through NEF, network exposure function they can connect to. So this is the overall concept of service-based architecture. Do we have Tejpal Singh ji today in the meeting?
Yes, sir, I am here.
So I think your point is getting answered, right?
Yes, sir. Actually, there was confusion when we see two reference architecture. I was looking from the implementation perspective. So how practically it will be
It is
implemented?
very important to understand the reference point architecture. Then only we'll be able to appreciate, because in a API based architecture, you may not be knowing that which network function will require what kind of service from other network function, because all are connected to each other. So, and for what purpose they are using. So we need to explain that first and then come to.
Sir. Sir, is there any significance of using this capital N then UDM just to have similarity between the reference point
These all are
nomenclature?
name. So they have just, these are just name of these interfaces. These are just name of the interfaces. Nothing else. You can give any other name, but in a standard, these names are given.
Right.
These are nothing but API interface.
Right.
Sir, in case of 2G and 3G also, the billing system is used to connect with the network using the standard connections. So what additional benefits NEF is bringing on the table for the 5G?
Okay, so NEF is like, so if you know about API based interfaces, it becomes very, very flexible, right? In the sense that it is kind of platform agnostic. For example, if you look at our Aadhaar system, Tejpal ji knows that our authentication services are exposed on API. So whether the other party is on Windows platform or Linux platform or Android platform, doesn't really matter. You can just fire an API call. So it becomes a platform agnostic. That is number one. Security on an API call, these are normally, we call it RESTful API, right? So if you ask what is your name, it will just tell the name. So and you may not be able to enter inside the network for any other wrong purposes. So some security aspect is also taken care once you expose your data or log onto the API. So that's a generic benefit of a API based interface. You can Google it. A lot of so today even the UPI, which we see the banking revolution UPI in India, that is also API based interface. We are able to connect so many banks on API, and even the Google Pay behind can be any bank, and you are able to use. So that's the beauty of UPI. That entire banking system, in spite of being connected through various apps, are safe and secure, and they are able to do wonder, right? So that's the advantage. Sanjay, is it okay?
Yes, sir. Yes, sir.
Okay. So now we will talk about NRF. Yesterday I had spoken about a little bit about NRF. NRF is Network Repository Function. So basically it stores detail of all other network functions. So whenever a new network function is installed or created, it has to register into NRF. When it registers, so its IP address or its fully qualified domain name and other profile data is actually registered into NRF. So it has got kind of a directory or index of all the network function. If a network function has multiple instances, so every instance is registered kind of. And also, I mean, network function may undergo certain change or modification during lifetime. So whenever there is a change or modification, it has to register again with the NRF. So NRF will always have the latest information about all other network function. So this aspect we call it service registration in the NRF. Thus, and it of course maintains the profile of those network function and number of instances. Now the next is the discovery part. Suppose one network function want to talk to other network function. Yeah.
Excuse me, sir. Sir, this who allocate this NRF? Any nodal agency or because it may be a unique feature for,
no, this is
for the
just
network.
a network function for keeping the detail of all other network functions, kind of a directory. So it is part of 5G core. When you install 5G core, NRF is one of the network function which you have to make it up. I mean, initially this will be the first network function to be made up because it has to register all other network functions. This is the first one which comes up, and then other network function will come.
Because in our 2G or 3G network scenario, we were allocated some kind of GT for any device, any network element.
Let me tell you that for 2G, 3G, 4G, this NRF was not required because NRF is only required when you have some kind of service-based architecture. In case of 2G, 3G, there is a point-to-point interface already available, which I spoke about 5G yesterday. That point-to-point, every network function is connected to other if required. Here, network functions are not connected. They are on a common bus and they have to talk on API. So where other network function is located and all is not known, right? So NRF is important or necessary in only in the 5G environment, not in the 4G or 3G or 2G. Okay, let us not.
Okay, sir.
So now suppose network function 1 want to talk to network function 2. So it will not directly talk to network function 2. First, it will talk to NRF. So that we call it discovery and ask about the network function. And this will give list of, suppose it is want to talk to AMF. So it will give the list of AMF with their profile. Now this network function can decide which network, which AMF it want to connect to, and then since now it has got all the addresses, it can actually have an API call with the identified AMF. So that is how NRF, what is the function of NRF? This one yesterday I had discussed while discussing that.
But this will, sir.
Yeah, go ahead.
This will cause impact on the load situation. I mean, every time if it is receiving a list of names and along with the IP addresses, not names but the IP addresses, and it has to select that which IP address it has to communicate to, then it will inadvertently lead to load more load in that node.
So basically, it may not be required so frequently. Suppose once the network function has discovered the correct network function, then it will continue to work on that, right? In some cases, wherever required, wherever the other network function feels that it has to take the list, it will take. Otherwise, once it has taken, it will continue to do API call with the respective network function, right? So there will not be much load.
But
and
what
it's very simple. It's very simple protocol, right? So I don't think it will create any additional load or any load unwanted. Yeah, please go ahead. What's your question?
No. I was just thinking that if that node in the meantime has gone down with which it was communicating, then again it will have to fetch that list from that NRF.
Yeah.
But
yeah.
first it will detect the failure from that node, and then again it will be going for a fresh list.
Yes.
It will be requesting a fresh list from NRF.
You are right. So this is just like any IT system, any network system. So they are also, suppose even in browsing, you have to do a DNS query and all, right? It's a similar process. In IT world, such processes are very common. So it's nothing new about 5G. It is just an IT thing which is being adopted here, right? So it's a standard process.
Right.
Now let us talk about the next network function, which is network exposure function, NEF. And I said that NEF is for exposing the capability of 5G to outside world. So it exposes API outside the 5G network function. So maybe different services will also use. For example, one I talked about OSS and BSS, which may be required to talk to 5G network for information. There can be services, for example, IoT services or V2X services, which are third-party services. They will also connect to 5G network through the NEF, right? So that means it exposes the capabilities. May I request to mute your mic? I think somebody's mic is on. May I request yeah, thank you. And the second is that security aspect of exchanging the information with 5G. 5G network has to be secured. So through exposure through NEF via API, we will make it much secure. And then finally, it also act as a translator, because on an API call, so there may be a different way of interacting with the third party services. It will convert into a kind of language which 5G understand, right? So it's a kind of translator also.
Sir,
okay, next, yeah, please.
Sir, the 5GS is connected to the external world via the data
NEF.
network also and the NEF also. So what is the difference?
Okay, so when I say data network, so data network is kind of so you are saying services, right? So normally I'll just explain this here in the. So here what you see, this application function, right? AF. This application function can be part of 5G core network. That means it can be inside 5G core network, or it can be outside. So suppose this service is being offered by the same operator, so it can put inside the 5G core. And suppose this is a third party application, so this may be a gaming service or AR/VR service being offered by third party. In that case, it will be outside the core. In that case, it will connect to 5G core through NEF. So although, and this data network are those data network which are part of the 5G network itself, right? For example, if they have their own internet or some service, so this is part of that. So basically there is a thin line between application function and data network, because suppose it is an IMS for voice service. So IMS is outside a third party application, maybe owned by the same telco. So this is one of the data network. If it is owned by the same operator, then it will form part of the core network itself. Otherwise, it will be outside. And this data network can also be onto the edge, in the sense that it will be near to the user. So for example, if it is a gaming service, so that application will be near to the user. So application functions and data network are more or less same, depending upon who is offering this service. I don't know whether I answered your question.
Yes, sir. Yes, sir.
Shall I proceed?
Yes, sir.
Okay, so this is next network function is network slice selection function. So all of us know that 5G has a concept of network slicing. That means you can create virtual networks for different services within the 5G core, right? Maybe you have one slice for offering voice services, other slice for offering autonomous car, next slice for offering smart meter service, and so on. So you can have multiple number of slices within your 5G network. So how to handle that? So there is a network function called network slice selection function, so the function will be that which network or which network slice instance is to be selected for a particular user. So for that purpose, it assists AMF, because AMF is the point where user connects. And then it also determines whether a particular slice is allowed or not. And the third function is that it assists to allocate appropriate AMF for the required slice. All because the AMF can be different for a particular slice. There can be multiple AMF that will form part of a slice. Suppose there are 5 slices, so in every slice there may be a different AMF. So the proper AMF selection is also done by, NSSF help in doing that. So this is the broad function of network slice selection function. And application function I talked about. That application function means any service will be offered through application function capabilities. And application function role is also in influencing the traffic. When I say influencing, in 5G there is a concept of edge computing. That means the user data, some of the user data can be offloaded onto the edge itself, and some part of data may be required to go to some central system. So this influence on traffic routing, whether it has to be local breakout or it is to be sent to a central server, is also, application function support in doing that, along with the PCF, policy control function. And then application functions will be accessing the network through NEF, which we discussed in the previous slide. An application function also need to talk to policy control function. Why? All because if this suppose application is a kind of a AR/VR service, and it will require a certain quality of service. So this information it tells to PCF, policy control function, and accordingly policy control function will talk to SMF, and SMF will actually provide quality of service through the UPF. So that's why it also gets connected to PCF. And that's why if you see that the PCF is connected to data network and application function in the overall architecture. And then you have authentication function. It is very, very similar to a previous generation. So it's just an authentication server for the authentication purpose, and all the security procedures which happens on the 5G, it helps that. So those were 5 network function I talked about, but there are many other network function. If you go to the specification document which I have uploaded on Team, so there are many. So we'll just look at that. AUSF we talked about, AMF we talked about, data network we talked about. Now there is one network function, we call it unstructured data storage function. So basically 5G also support unstructured data, mainly for the purpose of supporting IoT services and all. So it has got a network function. NEF we have talked about, NRF we have talked about, and this is network slice specific authentication and authorization function. So with the name itself, it becomes clear that when a user is entering into a slice, there is a next level of authentication and authorization within the slice also. So you have a network function there. And this we talked about NSSF, PCF also you have spoken, SMF also, UDM also. And then you have unified data repository, which I'll cover in the upcoming slide. UPF we have talked about. There is one network function called UV radio capability management function. In the previous session, I had talked about BWP, bandwidth part. So that means all UV will not support the entire band. So some UV will support a particular frequency band. So UV have got certain capability. So this is the capability management function. So once a system knows that what is the capability of a user equipment, accordingly resources are allocated. AF we talked about, UV we know, and then we have radio access network RAN we have talked about, and then equipment identity register, your EMI details are here, and then you have data networks analytics function. So this is very important. So here all those AI ML aspect can be actually deployed once you have huge lot of data coming through the network, and there is a network functions, you can deploy AI ML related functions, and of course you have a charging function. Not only that, we have a network function called non-3GPP inter-working function, which is to connect non-3GPP access, which we'll talk about. Similarly, we have trusted non-3GPP gateway function, wireline access gateway function, trusted wireline interworking function. Then we have service communication proxy and security edge protection proxy. Some of it we'll talk about in upcoming slide. So there are many network functions, and this is up to release 16, 15 and 16 combined. In release 17, which was just released, some more network function has been added. So let's go through that. So we talked about service-based architecture. Now let us have a look at service-based interface. The concept, the broad concept. This picture is also taken from the specification document. So in 5G, suppose this is network function A and this is network function B. This may be AMF, say this may be SMF, for example. So every network function is producer of some service, right? And it may also be a consumer of some service. So in case it is in producer and this service is required by network function B, so it will request, give an API call, and it will give a response, request and response. Similarly, in this case, this is the producer, network function B is a producer. So it can be consumed by network function A. So one is request reply, other is kind of a periodic information, so notification kind of. So in that case, you have to subscribe this network function, subscribe to a service, and whenever that event is happening, it is getting notified. So this is a kind of a service-based interface, a generic one, which is implemented in 5G, and that's why we call it service-based architecture. Now the next point is roaming reference architecture. So how in a roaming scenario architecture will look like. So this picture I have directly taken from the specification itself. I'll just explain to you a little bit. In case of a roaming, the two network, this is the home network and this is the network where a customer is visiting. So we call it VP element and this we call it HP element. So there is a new network function added, which is called security edge protection proxy, because the two networks are getting connected on some interface called N32. So there is a security requirement, right? So we have SEPP installed both sides. And this example of roaming is, we call it local breakout. When I say local breakout, what I mean, suppose a user who belongs to this network has come to this network, roaming here in this network, right? So now suppose it is accessing data. So in this case, what happens that the data is handled here in visited network itself. So it goes to its UPF, then data network, and whatever service it is asking for, the visited network is offering that service. So this is called local breakout, that locally the customer is being served. But one important aspect which is different from 4G is that the authentication of this user is in fact done by the home network itself. The decision of the home network on authentication becomes the final, which is slightly different from the 4G, where decision was being taken by visited network based on certain vectors which it receives from the home network. But in 5G, the complete decision is taken by home network. So this is also a security enhancement in 5G. So this is an example of local breakout. There is also concept of home routed. In this case, what happens if the user of this network, HP element, it has gone to a roaming network, VP element, and want to access data. So in this case, what is happening is the services are being given by the home network itself. So that means the two network gets connected. Control part here N32 interface and user data goes on N9 interface. These two UPF of the two networks gets connected. So actual services are being offered from the home network itself, although I am in a roaming environment. So this is called home routed roaming architecture, where data traffic is being routed to the home network itself. So both kind of architecture is possible in 5G. There is one more addition, that when you connect these two UPF, it is not straightforward, but certain security aspect has to be taken care, and for that there is a concept of IPUBs in between coming. So IPUBs is nothing but inter PLMN user plane security functions. Some security aspects are built in, and then those two UPF are, so those two UPFs are not being directly connected, but they are being connected through IPUBs on the both side, so that security aspect is taken care. No third person is able to enter into the network. So this is called home routed roaming architecture. I was talking about data storage architecture. So in case of 2G, 3G, 4G, what used to happen that whatever network function you are having, corresponding data storage was within that network function. In case of 5G, you have a separate UDR, data repository, unified data repository. So be it subscriber data, policy data, structure data, application data, those are in a separate data storage schema, and all the network function, for example, UDM, PCF or NEF, if they have to access certain data, they access it from the UDR itself. For example, the subscriber data belongs to UDM, so it will have access to subscriber data. The PCF, the policy data is for PCF, so PCF will have access for policy data. NEF may have exposure to structured data, maybe CDR or any other aspect which it has to pull, so it will have access to those data and so on. So your data storage is decoupled from the network function, and it is altogether a separate, just an IT world architecture 5G has followed. Now I have come to non-3GPP access. When I say non-3GPP access, what I mean is that the 5G core can connect even the network, say landline network or any broadband network or Wi-Fi network, right? So I'll just explain to you how it functions. So three types of non-3GPP access we had seen. One is the untrusted, other is the trusted, and third is the wireline. So let us talk about them one by one. So look at this picture very carefully and try to understand. So assume that this is a untrusted non-3GPP network. So normally 3GPP network you have G node B here, or we call it 3GPP access, and then you have AMA, FSM, all network functions are inside, right? And here you have untrusted non-3GPP access. Let us assume that this is a kind of a Wi-Fi, right? So the Wi-Fi network can actually become part of the 5G core, can connect to 5G core, and any UE, suppose this is user equipment, 5G user equipment. Now it has got two options. One is that you can connect to G node B and use. Other option it has that it connect to the non-3GPP access, and in this case also it can connect to 5G core. So what happens in this, that you require a new network functions called N3IWF. N3 is non-3GPP, IWF is inter-working frame. So which converts the protocol of non-3GPP access into the protocol which the 5G core network follows. Although here it is shown in a reference point architecture, but you can have even the API based call between them, right? Wherever it's possible. So what exactly happen is that a tunnel is created for control signal. A tunnel is created till N3IWF, and UE is able to talk to AMF on the same N1 interface, same protocol, and this non-3GPP access becomes transparent. It just gives a tunnel, just gives an IPsec tunnel for the control signaling. Similarly, for data also another tunnel is created up to the N3IWF, and from here it connects to the UPF. You recall that, right? For user plane, this is the path from here to here. So non-3GPP access becomes very transparent, and the data traffic can go here. So now let me again explain you that the user device here can connect to 5G core either through the G Node B or through the Wi-Fi or non-3GPP access, and it is possible that it can connect through both the access simultaneously in one go, and it can enjoy double data rates, or it can connect to one of it. So that is also a possibility. But interface for the UE remains same. N1 interface here for connecting to AMF, and for this untrusted also, when it's connect to N3IWF, it is again N3 interface towards UPF. So this is the concept. Any question here?
I have two questions, sir. My first question is when a user while roaming, how it's decided it's a local breakout or home routed? And my second question is this tunnel is in this 5G core net in this slide. This IPsec tunnel is NW or Y2 or both are the tunnels, Y2 also, and tunnel is used for only for the data plane or for the signaling also.
Okay, good question. So basically UE has to talk to AMF because AMF is the entry point for UE. So since here it is some other access, so what it does that till N3IWF, some kind of tunnel is created for control signaling, and then N3IWF transparently, just like G Node B, passes it to AMF. So basically, this is the same N1 interface which was there with G Node B through non-3GPP access by creating a tunnel. So that is for control. For data also, a second tunnel gets created up to the N3IWF, and from N3IWF there is a standard N3 interface which is also there from G Node B to UPF, similar, and the data traffic goes in the user plane. So the tunnels are IPsec tunnels are till N3IWF, both for control and the data. This Y1 and Y2 interface are specific interface to talk to this non-3GPP access, right? So initially, before tunnel gets created, the UE has to talk to this non-3GPP access. So there will be some capability built in the UE by which it will talk to the non-3GPP access initially, and non-3GPP access will talk to N3IWF. So this is a kind of a control signaling between UE and non-3GPP access, and N3IWF. For that, Y1 and Y2 separate interface are provisioned for. And then your question was about roaming, whether how to decide whether it's a local breakout or home routed. So this will be decided by the two operators, right? So two operators, when they will have roaming agreement, they will decide that whether they will have local breakout, or they may have a home routed, or they can have a mix of the solution.
Okay, sir. Sir, here one more question. Like you said that IPsec tunnel will be created. Sir, as per my understanding, for IPsec tunnels are used for the security of the user data. And for this signaling purpose, one time we do the this authentication, like you explained also that we use the akka algorithm for the authenticate, which you explained about the IMSI. At one time it is its authentication done. So first, one question is ki, in this UE, who will decide that it will be connected via 3GPP network G node B or via N3IWF node? And it's for UE for every time it do the connection, every time it has to do the authentic, do the make connection with the both the network, or how it's decided? Service every time service based, or once the user equipment get switched on, it remain connected with both the network.
So very good question from you. So there is a concept called ATSSS, and this I'll talk about in after 2-3 slides, so it will become clear. Broad answer what I can give you is that it's the capability of the 5G core when operators are able to build. In that case, what will happen, that there may be a possibility that when user gets a better signal of say either G node B or say non-3GPP access, whichever is better, you will actually connect to that and use the data. That is number one. Number two, it is possible that that if I am moving from one place to other place, from my home to say office, so initially I may be connected to the home Wi-Fi, which is a non-3GPP access, but when I step out, at that point of time my signal becomes low for Wi-Fi and becomes strong for G node B. So there may be a smooth handover from non-3GPP access to the 3GPP access. And the third point would be that I am being offered data from the both access parallelly, so that my data rate becomes higher. So all the three possibilities are there. It will depend upon the network operator, what all they have implemented and what all they are offering to a particular user.
Thank you.
Okay. So these are text you can read later on. This is what I explained. So now the question is that earlier I said trusted, non-trusted, non-3GPP access, and now I'm talking about trusted non-3GPP access. So the difference is that if the same operator, so for example, at our home, in my home, I have Geo fiber. So Wi-Fi which I'm getting from the Geo fiber, and I am also have a Geo mobile phone. So when my voice call is routed through Geo fiber network, in fact, it is going through a trusted network as far as Geo is concerned. So that is a kind of a trusted non-3GPP access. And suppose other example is that mobile I'm having from Geo, but the Wi-Fi I'm having from say Airtel. Then also my voice is being offloaded onto the Wi-Fi, you might have seen. So this traffic is going through a kind of a untrusted non-3GPP access as far as Geo is concerned, right? So they deploy a certain more security aspect. So this architecture which you are seeing is similar. The only difference is this is the trusted non-3GPP access, and if it is a trusted non-3GPP access, then it is easier for an operator to deploy because it is kind of its own network, but we call it trusted non-3GPP access. So here you have the gateway function and you have access point. That means your mobile has to connect to this network, and also this access point has to talk to core network. The rest of the functionality which I discussed in the previous slide will remain same.
Sir, a question here, a basic question here. I mean, how a UE decides whether the Wi-Fi is trusted or not trusted? I mean, how it decides whether to create a ITSSS channel or not?
Yeah,
or it will do the...
Yeah, please
Yes,
go
sir.
ahead. So these standards are already defined. So UV will look for non-3GPP access and 3GPP access, and once it is able to latch to non-3GPP access, the non-3GPP access will show that which PLMNs are available to be connected. For example, which, I mean, those configuration will be there in the non-3GPP access also. So it can select if it knows that the PLMN is being offered is the same on which the mobile is also operating, so it becomes a trusted one. If it is being offered some other PLMN, then that means it is a I mean, kind of a untrusted one, so other kind of protocol will run.
So is this intelligence built within the UE? I mean, at that.
Yes, the UV, yes, you are right. So the UV has to have these capabilities. So the UV which are being supplied today may not have this feature. So unless a latest version of UV you have, that may not work. This happened even in the 4G. You may be recalling that some of the phones are able to support voice call through Wi-Fi, and some of the phones are not able to offer, all because of that version of the phone, right? Earlier phone versions were not having. Okay, similar.
And one another question. Yes, sir. No, sir, you are saying something.
So I have come to the next slide. If you have any question, please go ahead.
One is what is the parallel to ANDSF in 5G? I mean, in 4G, we used to have a node ANDSF, which was a part of EPC core, which used to select which network it has to, which node network it has to, and it has to latch. So, is there any similar in 5G architecture also?
Which network function?
I mean, 5G also.
Which network function in 4G we spoke about?
Sir.
Pardon?
ANDSF. ANDSF, Access Network Discovery and Selection Function. Actually, the ANDSF used to assess the user equipment to discover the non-3GPP and the 3GPP access. Which one to latch to, whether Wi-Fi, WAX, LTE.
So here, as I said,
so is there anything similar?
So there is no separate similar network function. This non-3GPP IWF itself will do that perhaps. I have not seen similar network function as you talked about, right?
Okay.
Okay. So the 5G can also connect a wireline 5G access network. So in this example, this is 5G RG, a residential gateway which supports the 5G, right? So it can connect to 5G network or core either through the G node B or through a wireless access gateway function. So this is a 5G kind of a device, 5G access gateway, which will be there in our core network, and where residential gateway can also connect to it. Basically, it is just near to the UPF, it can be installed. So the residential gateways can also, the 5G residential gateway, the use case for 5G RG can be a fixed wireless phone. So kind of it will become a kind of a wireless fiber. You can say that you have a wireless fiber, so 5G RG. In case you have a physical connectivity, you can also connect to the 5G core through this interface. Otherwise, you can connect through the Z node B. So this is a concept of 5G RG. So there is some text you can read later on. And this is fixed network RG. The difference here is this is a general fixed network residential gateway, right? So it cannot connect to Z node B because it will not have the N1 interface. The residential gateway itself is not supporting N1 interface. So on behalf of this residential gateway, this wireline access gateway function will actually do the N1 and N2 signaling. So it is not, earlier we used to create tunnel for N1 interface, but since this function itself is not supporting N1 interface, so this particular function does that work. So this is kind of any fixed network residential gateway being connected to the 5G core. So what we discussed, that all kind of access can be connected to 5G core through a intermediate non-3GPP access function, which I explained to you. Now comes the ATSSS, which yeah, please go ahead. Some question here.
Sir, any interfaces available through which this 5G core can be connected to a 2G RAN or 3G RAN, so that whenever this 5G rollout will be there, so 2G or 3G network can also be connected to this.
Okay, so
either through network slicing or something, some mechanism.
So the answer to your question as of now is no. So whatever I talked about these solutions, I'll just a little bit explain more. That in USA there are residential gateway for broadband. One is based on a cable network, right? So there is a organization called Cable Lab or something. So residential gateway, we call it CRG, that can connect to 5G network. Then we have a broadband forum. So based on broadband forum, they have a residential gateway, we call it BRG. This can connect to 5G. And then Wi-Fi, our normal Wi-Fi can get connect to these are non-3GPP. So only these three kind of access, and of course 5G residential gateway, a new type of residential gateway. So these are four kind of access which gets connected to 5G as of now, not your 2G or 3G RAN as of today, but 4G can be connected. So 4G connection would be possible. Okay.
Because why I am asking, sir, this 5G can also work on 900 megahertz frequency.
Frequency is not an issue, because to support 2G and 3G, whatever is required towards the core and all is not there as of now. So as of now, I'm saying as of now, only these four type of options are available. So
okay,
it's not there as on today. Okay, ATSS. ATSS is your access traffic steering, switching and splitting. I spoke about it and I also gave a same example. That suppose you have a 5G network and also you have a Wi-Fi, 5G and Wi-Fi. So steering means ATSS ka pehla wala hai, steering means it will select the best network. If it is 5G, then connect to 5G. If it is Wi-Fi, then connect to Wi-Fi. Then the next S is your switching. My example of going to office from home, that if you are moving from one place to other place, so your 5G signal may weaken, Wi-Fi signal may improve, so handover will happen, seamless handover. So this is your switching, and this is your splitting, that your data can go through 5G as well as Wi-Fi, so you are aggregating the network. So this is a kind of ATSSS which came in release 16. Yesterday somebody was talking about. Yeah, yes, please.
Sir, in here is steering and switching, both are doing the same work. Even the steering is also, which one is the best, it is choosing. And the switching also, when we are moving from home
when I'm saying switching, it is the handover. But handover. Data call. You got my point. So if you switch on your mobile, so it will select the best network, right? So that's we are saying as a steering, right?
But steering switching is also happening, sir.
Pardon?
But steering switching is also happening, sir. Which one is the best? It will switching to that network.
So switching, if you say switching, steering is inbuilt, right?
Yes, sir.
If you say switching, steering is inbuilt. If you say splitting, so everything is inbuilt, right?
Yes, correct.
Okay.
Sir, I have one question, sir.
Yeah, please go ahead.
Sir, this the steering part, is this the facility to be taken or to be executed by the 5G service provider, or even the Wi-Fi provider can also enable this facility? Like in in USA, Google Fi services is available by Google. So in which these services is being provided and switching is being done from 5G to the best available Wi-Fi or vice versa. So my question is that whether the 5G service provider is able to switch the traffic, or Wi-Fi service provider can also be able to make over the handover.
So basically, if you make it as a trusted network, so it belongs to the same operator. Otherwise, it will act as a untrusted non-3GPP access. That is also so. In both cases, it will be possible. Suppose it is just an Wi-Fi, normal Wi-Fi, so it becomes an untrusted non-3GPP access, and these aspects will happen. If it is the trusted one, then I mean they can deploy a certain more configuration, because this Wi-Fi backend will also be connected to the same network. Got my point?
Yes, sir, I got that.
Okay. So now this is just I wanted to show. Yesterday there was a question about interworking of 4G and 5G core. So the same specification which I have shared with you is also having an architecture wherein 4G core and 5G core can interwork in a very smooth way. Rather, deployment would be possible that you can deploy HSS and UDM together, PCF and PCRF together, SMF and these gateways together. So these are the architecture, and there are interface defined between 4G and 5G. For example, between MME and AMF, there is a N26 interface. So this interworking architecture is also defined in 5G. Now there is a concept of SMS, right? So in 2G, 3G, everywhere we had SMS, and SMS actually is transmitted on the signaling itself. So 5G will also support that, and for that they have a SMS function, a new network function called SMS function, which they will be deploying. One more aspect in 5G, which is called 5G LAN. So generally what happens is that suppose a corporate want to have a wireless LAN kind of environment, then they can approach an operator and they can deploy this configuration for that corporate, wherein the traffic, so wireless traffic within that corporate will be routed with the local UPF itself, like here itself. It will not go outside the UPF, and here itself it will be routed. So there will be a local switch kind of. And suppose that corporate is having presence in the multiple city, so similar network they will have in multiple city, and they can connect these on a new interface called N19. So there is a concept of 5G LAN also. So today we have wired LAN. Now you can have a kind of a wireless LAN also. This also came in release 16. So with this, I close the 5G core part, and the next session is on quality of service. So let us take 5 minutes break and join again.
Sir, I have few questions.
Please go ahead.
Sir, in currently, I have a Airtel connection, and it shows that it's a 4G voltage. Okay, then when I make a voice call over the landline, it's possible to make a voice call. It means must be some gateways through which 4G call is connected with the landline call, PSTN call. So, like now you said that there about this backward compatibility from 5G to 4G is possible, but before the earlier generation it won't be possible. So, you mean to say that when the 5G will come from the 5G handsets, we won't be able to call to some landline, like from this 4G device, we are able to call to landline. When we will.
Salini, it's not landline. You are just using your Wi-Fi connectivity, the data connectivity from your Wi-Fi. They are using it because VoLTE is nothing but IP call, IP data call, which our handsets are supporting. And 4G has also, I mean, in the 4G also there was a specifications wherein this voice call offload is happening through Wi-Fi. Your normal data call is not offloading normally. You have to connect to the Wi-Fi and it's a pure Wi-Fi call, and your operator will, I mean, your mobile operator will not know. But in 5G, there is a possibility of even data call local offload onto the Wi-Fi or any non-3GPP access, and also the voice call. In 4G, they have done it for voice as of now, and for 5G, it will happen for all voice and data call. So it is any access it can use. Okay, let us take a break for 5 minutes and join again.